Okay. So, based on our what we call course plan, today we will look at the tutorial. So the previous quiz we have covered chapter 1, 2, 3, and 4, right? So I believe that we can skip this part because we have covered this in the previous tutorial. So for today's tutorial, we will cover the following 4 chapters. Okay, so just let me know when you don't understand the discussion so that I can explain to you. Okay, so let's start with chapter 5. Okay, as usual, previously, you can see that when you have this A, this is referring to the question that you can see the answer at the ends of the textbook. So let's just discuss the question that has no answers. Okay. So please open your textbook as well. This is page number. Where is it? Uh, Question 9, page number 152. Okay. So basically, I have opened it to you in advance. So question 9. Oh, let me accept your friends first. Okay. Mm, 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 mm. Okay, so chapter 5 is about, what is it about? Anyone can remember what is chapter 5? Chapter 5 is about hypothesis testing. So basically, this is just repetitions from what you have learned from your statistic in year 1. Okay, so let's have a look at the question. Okay. Question number 9. Frederick and Peter published an article in which they attempted to see if the pharmaceutical industry practiced international price discrimination. Okay, so when we talk about medical item, medical industry, this is very common when you talk about price discrimination, especially when you talk about severe disease like diabetes, uh, heart issues. So they kind of having this kind of price discrimination. So they want to check whether this industry has practiced price discrimination. How? By estimating a models of the prices of pharmaceutical in these 32 countries. So the authors felt that if price discrimination existed, then the coefficients, so how do they measure price discrimination? So they want to see that, they said that if let's say the industry did practice price discrimination, so the coefficient of per capita income, okay, in a properly specified price equation would be strongly positive. So you have to check your coefficient per capita income will be positive if let's say the price discrimination exists. So the reason they felt that the coefficient of per capita income would measure price discrimination. So normally we think that price per capita income doesn't really tells us about price discrimination. It will tell how wealthy you are, right? Whether it can measure your purchasing power as well. But in this case, they believe that it can also measure price discrimination because they said that this is their argument. The higher your ability to pay, remember, income per capita will be able to measure your purchasing power. So they said that the higher your ability to pay, the lower the price elasticity of demand for the pharmaceutical. So it means that when regardless of the price, whether it is increased or decreased, if let's say you are able to pay for it, so the price elasticity doesn't matter because people can pay for it. Okay, so the price elasticity of demand for pharmaceutical and the higher the price price discriminator could charge. It means that if you have purchasing power, so regardless whether they charge you with a higher price, you will still pay for it. Okay, so that's why they can say that, well, this income per capita can measure price discrimination. Okay. Um, um, um. So in addition, so before we go to an addition, so basically this is the per capita income or per capita domestic product. So you are expecting that this coefficient should be positive, because positive means that this company or this industry is practicing price discrimination. Okay, so next, in addition, the authors expected that the prices will be higher if pharmaceutical patent were allowed. Means that the country allow for having this patent. Okay, so when, for example, certain product has a patent, when you have a patent, of course you can charge higher price, right? So what is the patent? So let me go down to the uh, individual variable. So P is the pharmaceutical price level. So you want to see what are the factors affecting the increase or the decrease in the price of the pharmaceutical item. Okay, so one of the independent variable is the per capita income just now. And then they also have per capita, what is it? They also have per capita volume of consumption. This is just like the consumption of the pharmaceutical item. And then they also have PP. What is this PP? The dummy variable equal to 1 if patent for pharmaceutical product are recognized. Means that if, let's say, they allow to have this patent, of course, the price will be higher. Okay, this is what it says. So they expect that the price will be higher if patent were allowed. Okay. And price will be lower if price control existed. For example, government put a price ceiling. Okay, means that, okay, when you talk about a necessity item, for example, in Malaysia there are so many people who are suffering from diabetes, so you cannot charge higher than certain price because of the price control. So the price of the any medical things will be lower. Okay, so this is, where is it? What we call a dummy DPC, a dummy variable equal to if the country applies strict price control. So when the price control are in place, so the price will be lower, price for pharmaceutical item. And then if competition was, if competition was encouraged. Okay, of course, when you encourage competition, competition means if, let's say, you allow for entrance, the industries, other industries to come in, it will, what happen? Will lower the price. The more competitor in the industry, the lower the price will be. Okay, or if the pharmaceutical market in a country was relatively large. So if, let's say, the markets are large, of course, they will be competing with each other. So they will drop down the price. Okay. Okay, what is the next variable? A dummy variable equals to 1 if the country encourage price competition. Then it will have a negative impact on the price of the pharmaceutical item. Okay, so now let's look at the equation, whether they are following your expected sign or not. Okay. So this the per capita domestic product. This is like per capita income. Okay. So remember the author said that the higher the income means that the more you are able to pay for it, right? So of course the industry will charge you higher because you are willing to pay high. So it has a positive sign. And then this is positive. How about consumption? What is this per capita volume of consumptions of pharmaceutical in the country divided by the US? Okay, so consumption, the larger the consumption means that when you have a large consumptions of a pharmaceutical item, so basically the lower the price will be. Okay, because they have large demand. Okay, so this will be negative as expected. The patent when you allow for pattern, of course, the price will be higher. What else? DPC stand for, if let's say the country apply for strict price control, will be negative. Okay, you cannot charge higher than whatever certain limit. PC is price competition will be, if let's say government allow for price competition, of course it will reduce their price of the pharmaceutical item. Okay, so now somehow the equation, the expected sign follow whatever you estimated. Okay, let's look at the R bar square. 77%. This is cross-sectional. So for cross-sectional, this is a good estimation. Okay, so you are happy with the equation. So let's move to the next question. Develop, what is it? Develop and test appropriate hypothesis concerning the regression coefficient using the t-test at the 5% level. So basically, you have to do the hypothesis testing. Remember, chapter 5 is about hypothesis. So basically, you are testing all the coefficient. How many variables do you have? 1, 2, 3, 4. Let me just write down 3 examples. Okay. So so let me write it here. So when you talk about hypothesis, you have many ways. In the econometric slide, in our slide, we have like 4 main steps, right? But let me just give you the whole proper steps, 6 steps of hypothesis testing. Okay, the first one is, oh, this is too big. So 5 is good. So the first one is step number 1. Okay, what is the step number 1? You have to state your hypothesis. H0 and H1. Okay, and let me just write down for 3 examples. Step number, this is number 1 as well. This is for the second hypothesis, H0, H1. This is the third hypothesis. Step 1, this is also step 1, H0, H1. You can have H1, you can have HA. Both are the same. Okay, so you want to test for each of the independent variable. So you can put beta. So you can put beta 1 or you can put beta GDPN. So it's up to you. I will put beta 1 to make my life easy. And then second one, I put beta 2. I want to test it beta 3. Okay. So beta 1, you expect to have a positive sign, right? So beta 1 is positive. So H0 just the opposite and content equal sign. While beta 2 consumption, you expect negative sign. So the H0 will be the opposite and equal sign. Beta 3, what is it? Pattern. Pattern is positive and H0 is just the opposite and content equal sign. Okay, I will do it 3 simultaneously. The rest of 2, you can figure out by yourself. At least when I showed this working, you should know how to apply for the rest of it. Okay, step number 2. What is step number 2, everyone? Quickly. Forgot. Step number 2 is your alpha. What is the alpha? Alpha is 5%, 0.05. So the rest of it will also be the same, 0.05, the same. Okay, and then step number 3. What is step number 3? This is your test statistic. Because you are testing the individual one, so you are using T statistic. So T is given here. This is the beauty of doing econometric because you don't really have to compute using whatever formula. So T, they give you 6.69 for beta 1. T for this one, or let me put it here, 2, 3. Negative 2.66. And how about the rest? This is 1.19. Number 4 is your CV. How to find the CV? You still remember? You have to go to T table, right? Okay, we'll go to the T table. But remember for the T table, you have to play around with the DF, degree of freedom. So what is the degree of freedom's formula? DF is not n minus 1, right? So you have to take, what is the n? The n is 32 minus, you have to minus your constant, all the independent variable. So constant 1, 2, 3, 4, 5, 6. So you have to minus 6. So what will you get? Anyone with the calculator? 32 minus 6?
26.
26. Confirm? Yes. Okay, thank you. 26. Let's go to the table. Okay, where is the T table? Okay, so this is your T table. I hope that this table is clear enough. Okay, so under your T table, you have level of significance for one tel and for two tel. All of them are actually bigger, lesser, or bigger. So this is the example of one tel. Okay, so one tel. Next, what is your alpha? Alpha is 5%, 0.05. And then you have to go down until 26. Where is 26 just now? Which is 1.706. Okay, so you got the CV equals to 1.706. Remember? CV will tell you rejection region. Oh, the textbook is just next to it. Okay, so draw your what we call your diagram as big as possible. Okay, I cannot draw it bigger because my space is very limited. Okay, so the signs of your CV will follow the H1. So so here, if your H1 is bigger, your CV will be positive. If your H1 is less, your CV will become negative. Okay, so at the moment, your H1 is positive for the first independent variable. Okay, so let me draw here. Where is the rejection region here? So CV is 1.706. So this is positive, right? So this is your rejection region, 1.706. This is your rejection region. So you want to know whether you have to reject or do not reject. So let's see what is your T value. Your T is 6.69. Okay, so your T is inside the rejection region. So when it is inside the rejection region, what will be your conclusion? What will be your decision? So here, yes, you have to make decision, which is, don't just put reject. Reject what? Reject H now. Okay, so you are rejecting the H now. So when you are rejecting the H now, what would you say? So now step number 6, you have to interpret. How do you interpret? So basically beta 1 is, this is GDP, right? So this is testing whether you have the price discriminations or not. So what would you say? You reject it. So basically you have, this industry is actually practicing price discrimination for pharmaceutical item. So you just write down the whole thing. Or if let's say you want to make your life easy, if you want to interpret, you can say that you can just reread the independent variable, the per capita domestic product in the ICE country divided by whatever has a positive impact on the pharmaceutical price level. So you are saying that the independent variable has a positive impact or negative impacts on the changes in your dependent variable. So interpretation could be that way as well. Okay, so let's look at number 2. Number 2 just now. Okay, number 2, let me use different card. Okay, so for the coefficient for number 2 and 3, your CV will be the same. These are the CV, but you have to look at the H1. So for here, let me see which color should I use. Okay, So number 4 here, the CV is 1.706. But because it followed its sign, so the CV here will be negative. So when you draw your diagram, okay, CV will not be on the right side because it is negative. So it will be on the left side, negative 1.706. So you have to refer to T value. It is negative 2.66. So negative 2.66 will give you somewhere here. This is your T. So the result will also be the same, reject hash null. So how about the next one? Yellow color is not really looking good. So the next one is T is 1.19. How about the CV? CV will be the same. So number 4, CV will be the same, 1.706. But in this case, the CV is positive. So positive. So when you draw your diagram, I don't know whether I have a space. So it will be this side, 1.706. So this will tell you the rejection region. So what happened to your T? T is 1.19. Is it inside or outside the rejection region?
Outside.
Yes, thank you. So you see your T will be outside the rejection region. So number 3, your decision is do not reject hash null. Okay, and then you interpret. Okay, so I just give you the 3 example. I hope that the remaining 2 can be done by yourself. Okay, unless you will ask me you don't understand the steps. Okay, so let's move to the next one. Next question. Set up a 90% confidence interval for each of the estimated slope coefficient. Okay. So that's why I opened the chapter 5. I'm simply directed to confidence interval so that you know the formula, because they ask you to set up the confidence interval. So what is the formula? Because if we didn't write it here, you may not know what is the formula. Okay, so the confidence interval formula is equals to estimated beta or beta head plus minus, this is your CV, multiply with standard error for your estimated beta. Okay, so let's close the formula. Let's try to answer the question. So this is 90%, remember? Okay, so let's start with, remember you have to do for each of the independent variable. Let me just do one because I think this is just applying the formula. It shouldn't be that hard. Okay, so what is the first estimated beta? 1.43. 1.43 plus minus because it's interval. Okay, so you have to find the CV. How to find the CV for? I think we have computed the CV just now, right? What was our CV just now? 1.706. Luckily, I don't really have to go back to the table. 1.706. Okay, and then you have to multiply with the standard error of the beta. Where is the standard error? Normally, standard error will be given in the parentheses. This is your standard error. So multiply with the standard error 0.21. Okay, so if you want to compute the confidence interval, you have to start with minus. Minus will give you the lower level, and then you plus. Plus will give you the upper level. So can you minus first, and then give me the answer? Anyone with the calculator, quick. Who get the answer first for the minus? What will you get?
0.358.
Huh?
Ah,
For the minus?
1.07.
Yes. Like
ah,
I also click on my calculator, or else I will just follow the answer. Wait. Let me accept your friends first. Why did you just join late? Afif, geram ni. Okay, so 1.07. Let me put 1.07. Okay, 2 decimal point is fine. So this is for minus, and then what is the plus? plus will give you 1.7.
788.
Yeah, make it round it up into 2 decimal point. So you will get this interval. Easy, right? So can you do for the rest of the variable? Is it fine?
Yes, fine.
Yeah. So that we can move to the next question. I don't want to spend so much on applying the formula. This should be sufficient. Okay. Okay, next. What's next? What else? Number C. Do you think this? I don't know how to uh, pronounce this. Short and the Peter just now concluded that international price discrimination exists. So what will be your answer for this? Can you conclude that international price discrimination exists? Remember, they want to test whether this pharmaceutical industry apply price discrimination. So what will you say? What will you say just now? You are not paying attention. How do we measure price discrimination? Remember, they mentioned that the per capita domestic product is used as an indicator to measure price discrimination. So they hypothesize that this GDPN will have a positive impacts on the price. So when you test the variable and the variable is found to be significant, it means that the price discrimination exists. Have we tested for this just now? We have tested the hypothesis, right? What did you get? So remember, this is our first independent variable. So we got it, reject H naught. So you are saying that, of course, the price discrimination exists. Okay, so we have answered this question. Why? Why not? Why? Because we have found it to be significant, statistically significant, and it follows our expected sign. We expect that it should be positive. It is positive as well as significant. That is the answer. How would you estimate? How would the estimated result have differed if the author had not divided each country's price? Can you see that divided by the US, divided. Everything is divided. So if you don't divide it, um, do you think that the result will be different? What do you think if you don't divide it? Is there any difference? Hmm? Hmm. What will be your answer if let's say you don't have to divide by the US? Whatever later on, sometimes they divide the. Remember, when you want to find per capita, you have to divide by the population. US is like the population. When you don't divide by the population, do you think that the estimated result will be different? What will be your answer?
Yes.
Yes, it refers to what? Different or not different? So the answer is if you don't divide with the population, okay, basically the coefficient will change, of course, right? You will see the changes in the coefficient value. But when you divide it, basically your expected sign, whether it is positive or negative, uh, and the significance of the variable will not change. It will maintain the same. What make it different is just in terms of the coefficient. Instead of bigger coefficient, you're going to have smaller coefficient. That's it. But the most important thing in econometry is that you want to see whether they follow your expected sign, positive or negative, or whether the variables are significant or not significant. So with regard to these two, follow your expected sign and significance, it will maintain the same regardless whether you divide or not divide. Okay, dividing will make it smaller. That's it. Okay, you will see the difference just in terms of the coefficient. The rest will be the same. Okay. Okay, I think we have covered the first question. Okay, because you don't have the answer for this, right? So it's good to discuss with you. So let's look at the next one. You have the answer. You have the answer. Oh, everything has an answer. Huh. So do you want to continue discussing or one, we can stop here.
Con-
Continue. Okay, let's go back to the first example. Go to page 150. 150, question 6. 150, question 6. Okay. When I selected the question, I look at which question that give you the hardest question, the hardest, the toughest one. That's why I picked those questions. But I didn't realize that they have provided the answer. But it's okay. As long as the question represent the chapter, that should be fine. Okay. 6, right? Okay. Suppose that you estimate a model of house prices to determine the impacts of having beach frontage on the value of the house. So you want to see what are the factors affecting the house prices. Okay, you do some research and you decide to use the size of the lots instead of the lot instead of the size of the house. Okay. Okay. So basically, there are many variables that can affect the changes in the house price. So one of them is the size of the house. Okay, let me just write it here. I don't think when I explain, you can picture in your head. So let me just write here so that you can see. So this is the price of the house. Okay, determined by, let me put, is the functions of, you have the size of the house, you have lot of the house. Okay, there are a few other things. So let me just explain the first statement. So it says that in terms of these two, size and the lot, this question are actually taking, they decide to use the lot instead of the size. Okay, so well, basically these two are actually important variable or relevant variable in affecting the changes in price. Okay, so just to let you know, okay, so that you can make sense of it. Okay, when the size of the house increase, what do you think will be the impacts on the price of the house? Will the house become expensive when the
Yes.
size become bigger? Of course, right? Okay,
Yes.
but yes, but for the lot of the house, okay, so you know the lot is like the area inside the, like around the house. Okay, so in environment size, we call it the build-up area. So this is your house, right? This is the house. So if let's say your house is bigger, so the price will be bigger. But then lot means the area around your house. Okay, if let's say the area is bigger, basically you are not just purchasing the house, you are also purchasing the area, the land, right? So if the lot is bigger, what happened to the price? Of course, it will become higher. So although these two are actually relevant variable, but they decided to use just lot instead of the size. Okay, even though both are relevant. Okay, so they said that okay, they want to use lot, they don't want to use size. Okay, fine. Okay, so these are the estimation. What is this? This is I. This is cross-sectional data. So let's look at the, when you look at the equation, check the expected sign. Lot. You expect that the bigger the lot of the house, of course, the higher the price. So positive is fine. Age of the house. Do you know what is the meanings of age of the house? If let's say the house is just built in, right? Just you're gonna have a new house. So the price will be expensive. But after sometimes when the house is 10 years old, 20 years old, what happened to the price of the house? You are talking about the old house now. The the more age, the older the house, of course, the lower the price, right? People want to purchase new house compared to the old house. So we expect that it will be inverse relationship. Bed. What is this bed? Bed is the number of bedroom of the ice house. Okay, what do you expect? The more the bedroom, the higher the price? Is that your expectation? So do you prefer one bedroom or more bedrooms?
Oh.
Of course, right? So you expect that the bed will have a positive impact. Fire. What is this fire? A dummy variable for a fireplace. One, yes, for the ice house. Okay, so here just assume, let's assume that you are not living in Malaysia. You are living somewhere in the four season country. Can you give me any country that you want to live in? is it? Four season. Huh? You love to give your own example. Give me your country, your dream country. No dream country
Finland,
other than
Finland.
Malaysia?
Japan.
Okay.
Turkey.
US.
Okay. US is not a safe place, isn't it? I don't know. But okay. Let's assume that some of you wanna go to Finland, Japan. Okay. Let's stick to one, Japan, for example. Okay. Okay. So do you think that place is important in a four season country? Because you're gonna have winter. Do you need fireplace?
Yes.
Yes.
Yes. So what do you expect? Do you expect when you have fireplace, it will reduce the price of the house?
No.
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 So you expect fire will have a what? Positive impact. Or else
This impact.
you will be frozen inside the house. Okay? Beach is that your house is in front of the beach, right? So of course, those who are living near to the beach, the price will be skyrocketed, of course. Okay, so beach will be positive. Okay, now you are not happy with the fire. The rest of it, you are happy. Okay, it's fine. Okay, let's keep moving. You expect the variable lot, bed, and beach to have positive coefficient, of course, right? Create and test the appropriate hypothesis. So this is just testing the hypothesis whether these variables are significant or not. So I will skip this because I have demonstrated 3 examples. Okay, and then you expect age to have a negative coefficient. Test the hypothesis. Again, I will skip this. Okay, because we have done it. Okay. At first, you expect the fire, isn't it, to have a positive coefficient. We did, right? We expect you have a positive coefficient. But one of your friends says the fireplaces are very messy and are a pain to keep clean. Oh, because you have to put the wood and then it will be messy and to clean up is so hard. So now you are not sure. Is the sign positive or negative now? When it gives you hassle, it will give you what we call negative externality. So is this positive or negative now? So because you are not sure, remember when you are not sure the signs of the variable, you have to run two-sided test. So in this case, this is your question from the textbook. So they tell you run two-sided. But in the final exam, they will not tell you run the two-sided test. They will just test the hypothesis. So if you're not sure, use two-sided. Okay? Okay. And run a two-sided test around 0. So around 0 means this is what kind of beta? Via 1, 2, 3, 4. So you will test H0, H1. So beta 4 just now, right? 1, 2, 3, 4. Beta 4. This is beta 4. You are not sure? Not equals to 0, equals to 0. So when the question said run a two-sided test around 0. So you want to test whether 0 means no significant relationship, not equal to 0, there is a significant relationship. The rest will be just the same. Okay. What problem appear to exist in your equation? So what kind of problem? You have to figure out what will be the econometric problem. So they give you a hint. In the exam, you will not get this hint. So you have to remember when you talk about problem, you have to spot many things. So the hint here, because this is just from the textbook, right? Do you have any unexpected sign? Do you? At the moment, just now you expect fire is not following your expected sign, but now you are not sure. So this is okay. But the rest are fine. And then do you have any coefficient that are not significantly different from 0? What does it mean? Coefficient that are not significantly different from 0. It means that when you test the variable, is there any variable that are not statistically significant? Okay, you want your step number 5, when you make a decision, reject the H0. So in this case, is there any variable that you cannot reject the H0? Okay, so somehow from the answer, Because I haven't tested one by one, let me just check the answers right away. This is question 6, chapter 5. Do you have the answer for this? You do, right? Okay. So you do have a correct answer. I don't remember the answer. Which variable that are not significant? Let me just have a quick look. So the answer is page number 496. Question 6. Remember, 496. 96. Because we want to check, is there any variable that are not significant? So question number 6. Where is it? 496. Okay. Why is this? Question number 6, 4966 down here. Okay. Please check which one is not significant. We cannot reject H naught. What is this? Bad. So take note. Let me write it here. Bad is not significant. First, bad. What else? That is not significant. What else? We reject, we reject, we reject. All are rejected except for bad. Is it? Okay. What is this? Two-sided test. So we cannot reject H naught. What is this two-sided? Two-sided is the fire just now. Second, the fireplace. Okay. Let's go back to the question. Because we want to have a quick answer. Which one that is not significant, right? Okay. Let's go back to the question. Okay. Do you have any coefficient that are not significantly different from 0? So you have bed and fire. They are not significant. Okay. So let me double check on the bed and fire. Because they are not significant, it shows something. Okay. Bed. Do you think that this bed is irrelevant variable? Anyone? Or is it relevant? Let's check bed first. The number of bedroom. The more number of bedroom, do you think that it will have a significant impacts on the price of the house?
Yes.
So it is relevant, but it is not statistically significant. What happened? Okay. So in the real scenario, in the real example, of course, the number of bedroom are actually relevant variable. Okay. But you know, when you talk about housing price, the variable inside it, there are actually more than 20 variables that determine the changes in the house price. So some of the variables are very closely related to each other. For example, this is the example, the bed and the lot. How do they relate? Okay, so basically bed and lot may have multi-core issue. How? Because when the number of bedroom is high, for example, you have more bedrooms. What happened to the size of your lot? Will it become smaller? When you yes, when you have more bedroom, of course, the size of the lot will become bigger. So, having more bedroom is the same as having a larger lot, right? So that's why the bed is not significant because the lot has explained the bed. They are referring the size of the house. Okay, although bed is telling something else, but they are actually measuring the same thing, the size of the house. That's why bed is not significant. Somehow bed and lot has a multi-core issue. Okay, that's why bed is not really significant here. How about fire? Fire. Fire turned out to be insignificant. Do you think that when you are living in the four season in Japan, right? You don't need fireplace? Do you need a fireplace? Anyone?
Yes.
Of course, right? Okay. But actually, nowadays we don't use fireplace anymore. I can say that this is not really relevant in the modern time. You have a heater. Sometimes you, not sometimes, most of the time you have a build up a wire inside the floor, so that when you step on the floor, it will become warmer. It will be warm. So you don't need fireplace. You don't have to go to the jungle to find the wood to just fire up your wood. No, you don't have this anymore. So basically, fireplace is not really relevant in the modern time. You don't need it. You have a heater. Okay, so that's why fire is not relevant. Okay, basically you are including irrelevant variable, and then you are, for the fire, you are also including bed that has a multi-core with the lot. Okay, so that will be the problem. So when the question asks about problem, it's not just that you are checking each of the variable that you have in the equation. You also have to figure out, is there any other variable that has been omitted from the equation? Of course, there is no way that your equation will be perfect. So you have to figure out what else that can affect the change in price. Lot, age, bed, what else? What else do you think that can affect the price, that can make the price of the house become expensive?
The location, the type of the house.
Yes, perfect. The type of the house. If let's say your house is bungalow and your house is terrace, will be different, right? The type of the house, locations of the house, the facilities. If let's say your house is close to the city area, if your house is located next to the landfill, can you imagine? So there are actually many. Based on my study in Malaysia, I mentioned to you, right? Um, uh, Not just most will have some impact, most to the price, the tile, the floor, the types of the floor, the types of the material. So many, there are many. So you just have to figure out one variable to show that you have omitted relevant variable. Okay, so when you want to spot the problem, look at the sign, expected sign, does it follow your expected sign? Look at the uh, insignificant variable, check for the irrelevant variable, check for the omitted relevant variable. Okay, at the moment, just here. And you have learned functional form as well. Okay, so at the moment, the functional forms are linear, lin, right? But when you have age, basically age will not be linear. It will be quadratic. We'll look at this later. So you have to also check the functional form. Okay. So which of the problem that you outlined in part D is the most worrisome? Explain. Which problem? Remember when you have multi-core, for example, you have age and not age, you have bed and lot, you have multi-core. Multi-core will not cause bias. So you don't really have to worry about multi-core. What else? When you have including irrelevant, not so much. But remember, when you omitted the relevant variable, that will kill you. That will cause bias. So which one that will be a problem? The omitted one. Okay. What explanation or solution can you think of for this problem? How do you solve it? When you have omitted variable, what should you do? Include the relevant variable so that you can fix the problem. That's it. Okay. So yeah. So we have covered that. So let's keep moving. We have 426. So explaining the question will take some time, of course. So let's go to page number 178. 178, question 2. 178. You have been hired by Indo, which is Indonesian automobile manufacturer. Okay. What you need to do. So you are talking about 35 different American car. Okay. Okay. Let me look at the equation. So this is the price of the car, the factors affecting the price of the car. What is WT? Let me see. P is the list price of the car in thousands of dollars. W is the weight of the car. T is dummy if the car has an automatic transmission. C if the car has cruise control. L, the size of the engine. Okay, look at the variable. Do you think that when the car weight more, it will have higher price? Weight normally shows how durable the car is, how the body is strong. When it weight less, it's like Myvi, Kanchil, they weight less. So do you think that the weight will have a impact on the price?
Yeah.
Well, brothers, you know better, so you should tell us this. I don't have car. So T, if the car has automatic transmission, okay, so this seems okay. I think this should be positive. Weight also positive. If the car has cruise control, normally the expensive car has this function. The Kancil Myvi, I don't think they're gonna have this. Size of the engine, huh? Brothers, what is the impacts of size of engine? The bigger the size of the engine, what happened to the price?
You price.
Confirm? You know better in terms of
Confirm.
car? Confirm. Okay. So you're expecting all positive. Let me see the equation. Oh, all positive. Cool. And the R bar square is 92%. This is cross section. 92 is very large. Okay, let's look at the first. Your firm's pricing expert hypothesize positive sign for all, of course. Test. Okay. If you want to test your expectation, this is hypothesis testing. I'll skip this. What econometric problem? Remember, when you are given the question always asks you what kind of problem you can spot. So you have to familiarize yourself with the problem, because in the exam they will not give you hints. Find out what are the insignificant. No, you have to figure out. That's why we have this kind of exercise. What econometric problem appear to exist in model A? In particular, um, does the size of coefficient of C cause any concern? Why? What could be? Okay. So before we looking at the size of coefficient of C, C is what? Cruise control. Before we are looking at the size of this, can you spot the variable WTCL? Is there any variable that are irrelevant, or is there any variable that has multi-co-issue?
There are two.
Which one?
The engine.
The what?
The W and L.
Yes, the weight and the size of the engine. These are very similar, right? Luckily, you can spot this. So these are multi-core. And then the sign is fine. Multi-core. What else? Remember, you also have to figure out what will be the omitted variable. Other than this variable, what will affect the price of your car? Other than this variable, what affect the price of the car? Brothers, what
The
is it?
brand of the car.
The brand. The brand. Mm, okay, could be, of course. What else? The safety, the characteristic, the safety features of the car, whatever, right? Which I don't really know about the car, but you have to figure out one factor that you think is relevant, but it's omitted from the equation. Okay, you have multi-core, you have irrelevant variable in the equation, you have omitted. Okay, and then where is it? Okay, let's look at the size of the coefficient C. Let's see, C. At the moment, the variable 0.2, 1.2, and then 0.1. So the coefficient C are actually very large. So when the coefficients of the variable, one particular variable, are very large, it is an indicator of bias exists because of the omitted relevant variable. That's why the bias cause the C become larger. For example, the brand of the car has a positive impact. The more branded the car, the higher the price, right? So when the branded car has a positive impact and then you omit from the equation, so the positive remain in the equation. That's why the C become more positive. So that is the problem. Okay. Does the size? Yes, cause a problem because you have omitted. Okay. So what could be the problem? The omitted one. You decide to test the possibility that L is irrelevant variable by dropping it and rerun the equation. So let's assume that you said that L is irrelevant. So you run. Okay. So here you have another equation that has no L. So it says that which model do you prefer? Why? So you can see hint, right? In the exam, you don't have the hint. When they ask you which model do you prefer and why, remember you have 4 specification criteria. What are they? I purposely open it in advance. So you have to check whether it is supported by the theory, whether t-test is significant or not, R-bar square is high or not, whether you omit or you include it will cause bias to the remaining of the variables or not. Okay. So now, so let me write here. One theory. What happened? Theory supported by theory or not? 2 t-test. 3 r-bar square. 4 cos bias or not. Okay, let's close our slide. So let's check the theory. Size of the engine. Well, the bigger the size of the engine, perhaps it tells that the car is a good car. So that's why the price will be higher. So let's assume that the theory support the L. Okay, theory said okay. But then when you look at the size and the weight, this is giving multi-core. So you can either have one, cannot have both. Well, because you have multi-core, instead of giving, remember 1, so you will give 0.5. Remember each of them worth 1 and you want to see 4. Okay, next. What else? T-test. T to the T for L. Just now the L T can you use your calculator 0.16 divided with 0.2? What will you get for your T? What will you get? You know how to find the T, right? Coefficient divided with the standard error. Your T will become
95.
0.95. So 0.95 is not significant. So your T is not significant. So when your T is not significant, so you don't get any marks here. This is 0. Okay, just now this is 5, 0.5. Okay, what else? R-bar square. How about R-bar square? Previously 0.92. When you drop, 0.93. R-bar square is improve, right? Improve. So you get 1. Okay. Bias. Does it cause any bias? Previously, you have 0. Okay, let me see. The W 0.28, now 0.29. Not so much. Previously 1.2 for T. 1 point not change at all for the C. 5.8. Now 5.9. The change is just 0.1. So not so much different. So no bias. No bias, so 1. So in total, do you have to drop? If you drop, basically, the score is what? This is 0.511. So 2.5 over 4. Do you have to drop? T is not significant. Why do I put 0 for T? Okay, so T test is not significant, so you have to drop, right? So in total, it's like 3.5 over 4. Do you have to drop the L? Remember? Yes, right? As long as you get 2 over 4, you can consider whether to drop or not. But now 3.5 over 4, you have to drop L because L is giving more issues. Okay? So now let's keep moving. See, done. Okay. So, yeah. So let's keep moving to the next question. Do you think that we should cover question 4 or just move to the next question for next chapter? Should we cover the whole question? If let's say we want to look at question 4, we will have 5 more questions. If let's say we go to chapter 7 and 8, 2 more questions. Now it's 4:37. You don't mind? Huh?
Next chapter, madam.
Next chapter. Okay, good choice. Okay, let's go to page number 210. Which question? I forgot. 210, question 2. Question 2. Okay. So, so for each of the following pairs of dependent, y is your dependent and independent is x, pick the functional form. Remember, chapter 7 is about functional form that you think is likely to be appropriate. Okay. Now, let me open a new one. 7 is too large. Okay. So, y is your sales of shoes. And then it's a function of disposable income. So what will be the functional form? Is it lin? Is it lin-log, log-lin, log-log, quadratic? What will be the functional form, do you think? Remember income? When we learn about income, normally income will increase by percentage. Percentage means it is log. Sales of shoes. Remember we have learned when your income increase by a lot, your demand for something will not increase by a lot. For example, your income increase by, I don't know how many, 10%. You will keep eating the same thing. You will keep purchasing. Maybe you will buy 1 or 2 more shoes, but you will not buy the same increment as your income. So shoes or item will increase by unit. So this is lin. So lin log. Okay. Next, number B. B is what? Attendance at the Bollywood symphony concert. So concert attendance is functions of whether the orchestra's most famous conductor was scheduled to conduct that night. So the famous conductor, famous one. So whether. So when you have, okay, this is equal. So when you have what you call here, this is like a dummy variable, whether the famous conductor 0 or 1. So when you have dummy variable, the relationship will be linear, because it is dummy. Okay. So next, C, aggregate consumptions of goods and services. This is just like aggregate consumption. It's a function of aggregate disposable income, aggregate income. Remember income? Income will be log. Okay. So aggregate consumption, it can be linear, but when you talk about aggregate, this is like what you call macro variable. So macro variable, you are talking about many countries, right? Macro. So when it is macro, normally the amount will be large. So in common practice, you're gonna apply log. You can also have lin log. Okay. You can also have lin, but not so common. D. What is, we have under E. D, money supply are actually macro data, macro variable, money supply and interest rate. So money supply and interest rate, this will be log. Okay. And E, average production cost. This is production cost. Production cost is normally we call it output, cost of output. Output is a function of the number of box of pasta produced. Number of box. Okay, what will be the what we call functional form? What do you expect? The higher the number of box, the higher the cost, or the lower the cost? What is it? The more you produce the box, what happened to your cost if you are a company?
The higher the cost.
You have economics of scale. What does it say? When you produce small small output, so the cost will be remember, you have fixed cost, you have variable cost. When the output is small, so your fixed cost is large, so you want to keep producing more. When you keep producing more, you will get more profit, so it will reduce your total cost. Production cost is including fixed cost plus variable cost. So the higher your output produce, the lower the cost. But actually, the functional form is looking like this. You keep, this is your output. This is the cost or price. Let me put here cost. This is your output. Okay, this is economic class, right? So the output start from zero. So when you start producing your output, the cost is actually high. But after some time, you keep producing, the cost will keep falling and falling. Somehow the cost has covered the fixed cost and so on. So when you have this kind of diagram or graph, this is what you call quadratic. You keep increasing and then the cost will keep reducing. Okay, so done. So this is like what is this chapter? A functional form. Functional form is interesting. Next, page 241. Question? I forgot. Question 2. 241 question. 241, where is the textbook? 241 question 2. Okay. This is chapter what? Chapter 8. Chapter 8 is about multico. Okay. So let's open a new one. Okay. A recent study of the salary of the elementary school teacher. So you just want to know about school teacher salary in a small blah blah blah. Okay, this is the equation. Remember when you got the equation, check the expected sign and check the variable whether they are relevant or not. Okay, I don't know what is this variable. Let's read the definition. Salary of the teacher. EMP is the years that the teacher has worked in the school. So EMP is the years. Okay, why don't they put years? Okay, unit. The units of graduate work completed by the teacher means that the graduate work is like whether they have done a few training, they get certificate, certificate. Okay. Length, dummy variable equals to 1 if the teacher speak two languages. X, this is X, teaching experience. Okay. So what do you expect? The years the teacher has worked, the more years the teacher has worked, do you think that the salary will be more? Every year you're going to get an increment in salary, right? So the more years the teacher is working, the more salary they will get. How about the unit? Means that if let's say the teacher has completed a few certificate training, when you have completed training, what happened to you? You will be skillful worker, skillful teacher, right? Of course, your salary will be high. Languages. Do you think that speaking two languages has an impact on the salary of the teacher?
Yes.
How?
So like, if you can go and teach another subject in another language.
We are talking
And you
about
can also write your research paper in the other language that you know.
we are talking about school teacher,
Oh,
not
school teacher.
university.
Uh, don't know. School
School
teacher maybe they can teach two subjects lah, like English and mathematics, for example lah.
languages, not knowledge.
So,
Languages mean
so two languages mean they can teach another the language that they know as a subject apa? Subject yang what do you call that? Additional subject.
optional, additional
Ah,
course.
yeah.
If let's say this is about university lecturer, could be, but actually teacher, school teacher, you have a fixed course, right? That they can teach that will be available in the school. I don't know. I don't think languages. If let's say you are not talking about school, you are talking about working, like in the company. Some people are preferring for the bilanguage, like English and Mandarin, English and Malay. But school teacher, hmm, okay. I personally I don't think this variable will be relevant, but it's okay. Just KIV experience, of course, right? When the teacher has more experience in teaching, the salary will be high. Okay, so the first one is hypothesis testing. I'll trust you can do this. Second, what is the functional form for this equation? Because now chapter 8 is about multico. You have covered functional form in chapter 7. Do you think that the current functional form is appropriate? Explain. What is the functional form? This is the first one is log. This is log lin. Do you think that this is okay? Functional form. Remember when you talk about salary, when you talk about income, normally the changes are in percentage. That's why you have the log. So the dependent is fine. How about the independent? Independent. Looking fine, right? Dummy variable will be lin, years of looking good. Okay. Okay. Does it seem appropriate? Yes. So when the question asks you to explain, you have to tell why the dependent is locked, because income or salary are always change. Change in terms of percentage. So that's why you have to put the log. What econometric problem? Problem, you have to figure out the same thing, whether there are irrelevant variable, there are multi-core functional form, doesn't follow expected sign, insignificant variable. Okay, so you have to check. So at the moment, you have years. Can you spot any multi-core? Cannot? Years of teaching and teaching
And then
experience.
experience.
Yes,
Yeah,
right?
same thing.
Yes, the same thing. Although you call it different name, but they are the same thing. So you can say that you have included irrelevant variable. That's why it costs you multi-core as well, right? Of course, when they ask you about econometric problem, you have to figure out, is there any omitted relevant? Of course, there will be omitted. So you have to figure out, what do you think other variable that can affect the change in salary that you have omitted from this equation? Anything else that can affect teacher salary? If you still remember, we learned about private school, government school. So in the private school, normally the teacher will get more salary, high salary. So the type of the school, of course, it will affect the salary of the teacher. Okay, if let's say the school is like a village school, like what we call not the government school, not the private. So of course, the salary of the teacher will be very low. What else do you think that can affect the salary of the teacher, but it is omitted from the equation? Anything else? Anything else?
Their level of education.
Yes, of course. Level of education. If school teacher, right? School teacher. That's why the school teacher they use graduate work completed, because sometimes school teacher don't really need to have higher level of education. I mean, they can have bachelor degree, but when they have like master's, PhD, for the school teacher, those level of educations are not really required, but then they need some skill in dealing with students. That's why they have some training. Training will be more applicable to the school teacher, but higher level of education not so much relevant for them. Okay, other things? Okay, you can figure out. Okay, let's just keep moving. Suppose that now you are told that the simple correlation coefficient between EMP, which is years, and EXP, experience, is 0.89. Oh, this is high. Remember, when you have more than 80% for your simple correlation coefficient, you have multi-co. So remember, multi-co can be checked using simple correlation and then VIF. How about VIF? VIF just barely over 5. As long as your VIF more than 4, you have a multi-co issue. Okay, you can see that they are related. Okay, so does this change your answer to part C? Just now you mentioned you have multi-co. No, it doesn't change. It shows that you really have a multi-co problem. What remedy for the problem you identify in part D? In part D, you said that you have multi-co. So when you have the multi-co issue, how do you remedy? You can either drop one of them. So how to drop? Make sure that you check which variable that is supported by the theory. In the case of severe multi-co, doesn't matter which variable you can drop, they will give you the same result. But again, you have to check with the theory. That is the right way to do. Okay, if you drop EMP, which is years of working, so then you have you rerun the equation, you have this result. Which do you like better? Why? So when you have to compare between the model, remember you have to use 4 specification criteria. You have to check the theory, you have to check the t-test, you have to check the R-bar square, as well as the bias. Okay, I believe that you know how to do it. Okay, done. Done for that. Okay, let me see. So basically we have covered one question in chapter 7, another question in chapter 8. Okay, so do you have any other thing to ask? Or was it clear? I thought that we can cover the rest of it, but somehow time is very limited. Any question? Any question?
Terus now, somebody asked in the chat,
Not yet.
can we get the link for the recording?
What was the question?
Where
Why
can
do
we
you
get the
ask?
link for the recording?
Okay, we haven't finished our class. You already asked for the link. Okay. Okay. After this, I will put the the link in the YouTube. So I will share you the link in the where is it? In your course plan. Remember, I always put in the course plan. So you will see the link in your course plan. I will update your course plan. Okay. Your EVs also will be the link in the course plan. Okay. What else? Anything else? Any question? Oh, let me stop the recording while waiting for you.